understood a bit. Every third word I understood. So I'll get you apples later, whatever that. So a quick, first of all, congratulations on this huge, amazing building office. It is in, it looks very productive, so congratulations. How many of you are embedded consultants? Okay, you are embedded in the audience also, okay? And everyone else is, what, IT consultants? Working in .NET? Raise your hand. Working in not .NET? Okay, what are you working with?
Java.
Java! I don't like Java too much, actually, but I don't like .NET too much either, so it doesn't really, I'm very non-racial. I actually started about 16, 17 years ago, I started programming in Visual Basic 5 and 6. And to this day, I love Visual Basic 6. It was one of the best languages ever. I know that many people hated it, but let me tell you, if you knew what you were doing, it was an amazing thing. Those same people who were horrible in Visual Basic 6 and created that code that everyone hates today are those same people who write the code that everyone hates tomorrow, today, with today's tools. So it's not about the language. You know what I'm talking about. You probably know who you are also. Anyway, this is a topic that's near and dear to my heart. First of all, because I've always been interested in, whenever I was put into a project, I was always the crazy professor who was trying to automate everything. I always had this slogan, if you hate it, automate it. And there are so many things that I hate about software development. Most of them are all the stuff that is about deployment and doing all the stuff that is not the interesting stuff. Compilation and the running of the test and the deploying and the zipping and the generation of the configuration and everything. But in the past few years, it's also been about getting the feedback, getting the quickest feedback from the customer. And that's going to be the topic for most of our talk today. And I know you've also heard about test-driven development, and if you want, we'll also have time for questions about how test-driven development fits into all this. But this is going to be the main topic for the next 90 minutes minus breaks. If you want to learn more about this, just go to beautifulbuilds.com. A lot of the stuff I'm talking about is also in videos over there. And if you want to contact me via Twitter and ask me questions or give me answers, because I don't have all of them, just contact me via Roy Osherove. I also wrote a couple of other books about team leadership and unit testing, and somehow this all fits together. This doesn't exist as a separate entity. We can't actually exist in separate from everything from the system around us. So the leadership and the quality and the continuous delivery, all the operations and development and leadership, these things work together. They're all parts of the same whole. And I believe that someone who understands all these three pillars can be very effective in software development. Okay. So I'm going to ask a question which most of you probably already know the answer to, but you probably also have multiple answers to. What's the difference between automated builds versus continuous integration? And this is, hopefully this will be a little bit of a conversation, not just a talk. Because this is not Norway, right? Norway, everyone likes it when you just talk to them. But hopefully in Sweden I've heard that people are a bit more interactive. Right. So let's see if that's true. What's the difference between automated builds and continuous integration? Anything? Yeah.
Yeah, automated builds is building the software, while continuous integration is building software, running the test, maybe deploy the software, running more tests.
So
entire chain of
this is more than this, it just has more content?
Yeah.
Okay. Good, interesting answer. Yes?
For me, it's not quite like that. For me, I mean, automated builds, that's, I mean, of course we automate things because, as you say, I mean, it's so boring to do things. I mean, that's automated tests, builds, tests, everything, the whole complete flow to produce the output that you should be able to send to the customer by. Continuous integration for me is making sure that all teams are constantly, or at least at a daily basis, submitting their code so that you have a stable code base that's not spread around in different parts. So you have.
So this is more about culture, and this is more about the tooling.
I would say both is processes. I mean, how you work with.
Okay, that's very interesting. I never thought about it this way. Cool. Anything else? That's it. Okay, 2 answers. First 5 minutes, actually not bad. You're much better than Norway already. So here's the way I think about it, but I think I kind of like your answers too. So this is just one version of how to look at it. The way I think about it is that when people ask me I do an automated build, yes, I do continuous integration, I usually can tell when they don't do one of the other. You notice how it's turning... Oh yeah, I have Flux enabled. You know what Flux is? Who works on Macs here? Flux, where are you? So there's this application called Flux, and there it is.
John did.
Okay. It was sunset all of a sudden. Anyway, it's application supposed to make your eyes not bleed as you work into the night. Okay, so to me the difference between automated builds and continuous integration is that in an automated build I might have a script and that lists all the things that I would like to do in an automated fashion. And then if I click a button, that actually happens. So think about automated build tools like Nant, MS-Build, Make, etc. And then continuous integration to me is the trigger, is the decision of when to do this and to do this continuously. So this actually triggers that one. So I can have a lot of automated builds, but I don't have continuous integration if I don't trigger them constantly on various events. So scripts versus CI servers. We have a distinction. We talk about continuous integration. What kind of continuous integration servers do you use today? Examples? Jenkins. What else? Sorry, Jenkins. What else? Bamboo. Okay. Anything else? TeamCity? TFS? Dear God, no. Yes? Yes. Sorry to hear that. We'll talk about why. And if I don't answer that, feel free to ask me. But today I believe that TFS as a CI server is it's not equipped to deal with the reality yet. So CI servers versus scripts, there is a difference between those two things. There is a difference in the way that I think they should work in the world. And I give them different pieces of information. If a CI server triggers a build script, then a CI server has a different context, a different piece of knowledge about the world. For example, a lot of times we can save build scripts in source control. And many times we don't, although we should, save the configuration of the continuous integration servers in source control, and we don't. Many times we get things wrong about how we treat them. Here's what I notice, is that the best, most effective way to use these two different tools is that to treat them like ops and DevOps. CI server should have the context and the knowledge about the environment, names of servers, FTPs, passwords maybe, and the build scripts have knowledge about the development, the structure of the source code. So the source code knows how to build itself. The CI server should not know about the structure of the source code. They have two different pieces of knowledge. Now, maybe it seems like maybe I just made that up, right? We have two things. Let's just put two different things, two different requirements on them. Because a lot of people like to do everything in one of them. So I want to talk about exactly why we should separate these two. The most obvious reason, but we only come across it when we start doing it wrong, is that application code changes at a different rate than operation knowledge. So we can change servers regardless of changes to the code. We can change code regardless of changes in the servers. And if we save everything in one location, then we keep having to update that one location when there are changes that don't make sense. Like, I shouldn't need to change my build scripts if I change the name of an FTP server in source control. I shouldn't go and configure the continuous integration environment if I added a folder into my source. But those are exactly the things that I have to do. If my build script is usually, I like to save it in source control, but hopefully CI server too. But what happens when I don't? The CI server that I personally like to use these days is actually TeamCity. And all the examples you're going to see today are from TeamCity, but a lot of it applies to most of the other servers. And a lot of people like to use TeamCity to contain both the triggers and also the scripts that run inside the triggers. So there's also logic for when to compile things. There's also the logic of when to trigger it, and it's all together. And the problem with this is, here's one example of a problem. If we have the script embedded in the CI server logic, and in version 1 of the application, we had in our root of the source control, in our source, we had a folder of tests, and we just would run all the tests in that folder. In version 2, or a month later, we decided, you know what? We actually want to have a separation between unit tests and integration tests into 2 different folders. That's actually a very good idea. We should have 2 different folders for unit tests and integration tests, because unit tests are fast. They should always be passing. Integration tests not always passing, actually. We want to have that separation. You figured this out, but now you created this. Unfortunately, the CI server starts breaking because you now changed the name of a folder. Or even worse, it continues running just fine without telling you that maybe if that was still called tests, it continues just fine, but it never runs the integration tests. So you don't even know that it should have changed it. So that's an example of separation of concerns that didn't happen. We can also have the opposite. But basically the idea is that when you couple application source to the operations knowledge, then you have to change the operations when you change the source, which is exactly what we don't want to do. So this is a better way. If we have the scripts inside source control, then the script to run the test gets triggered. But the script is always in the root. So the CI server knows nothing except just to trigger a script in the root of the folder. And then when I change the structure of the source, I change the script inside the source, and the CI server still triggers the same script. But if tomorrow I want to try to test and maybe roll back to the previous version, I don't have to do anything because the previous version also has the previous script. It will just work. So the code knows how to build itself. The CI server remains a dumb trigger. Here is the opposite case. In this case, we have FTPs, and we renamed an FTP, or we moved all the files to a new FTP. But in our deployment scripts, which are in source control, we have hard-coded the name of the FTP. So now we have to actually change and check in our build scripts and create a new version in the source code just so we can deploy to the new FTP, which doesn't make sense. This is an operational thing. I should be able to just go to the CI server, change the name, and all the build script will just work. So this is the opposite. If you couple the operation knowledge to the application source control, then the source has to change when the operations change. This is a better way to just have placeholders or parameters or variables in the script. Sometimes I would set up environment variables that the script would read. Sometimes it's just command line arguments. But the CI server is the one that holds the knowledge about the name of the FTP. So I don't have to create a new version. I just have to change the setting here in the CI server. This could also give us the ability to give different people permissions to change that knowledge. We don't have to have all developers knowing all the passwords to all the servers. But that's all different from continuous delivery. So we had continuous integration, we had automated builds, but continuous delivery is something to me, a bit higher level. I think it a bit connects to what you said before. What's your name?
John.
John. What John said before about that it's more of a cultural thing. Because when I say continuous delivery, to me it feels more like a process, more like something that I would care, that's more of a human kind of problem. It is the connection between those two other things. It is the way our code goes from us to the customer. It's the way from between an idea and a customer actually using the product. The continuous delivery is about drawing a line and hopefully even visually seeing that line and seeing the code going through that line until it goes all the way to a customer that's using it. But I was working in a project, actually just here in Norway, and this was a government project. And we were, there was a simple Scrum team, and we had a product owner, and everything was great. We were running sprints. We were doing sprints every couple of weeks. I think I have a phone call. No, that's not me. And every couple of sprints, we would deliver something, and that's okay. Every 2 weeks, we would have a sit down and we'd show the demos and all that stuff. But I kept pushing for more continuous delivery, to deliver every day, to push to production every day. I knew it could be done, and I was pushing for it. And the product owner, which was a really nice guy, he came to me and he took me aside and said, "Look, Roy, you're a nice guy and everything, but why are you pushing so much for this? I mean, I'm happy. I'm the product owner. I'm happy with the current situation, right? So why do you want to change it?" And actually, when he asked it, first, I didn't actually have a good answer. I knew that continuous delivery was a really good idea, but I couldn't put it into words. I knew that it made sense. So at the beginning, I actually told myself in my head, maybe it is just about ego. Maybe it's just a programmer who wants to play with things, wants to automate just to do the next cool thing, right? Just like you play with a cool language or whatever. But it's not that. And I asked him this, and I came up with an answer about a day later. I said, "I'll get back to you about that," which of course was not a good thing to tell the product owner. Why is the thing you're pushing so hard for? Why do you want to do it? I'll get back to you. Right? Not a good idea. But I really had to think about it. I didn't want to just, bullshit him. So here's what I ended up with as an answer. So first of all, I asked him, can you imagine what would happen if we had to wait 2 weeks before we compiled the code? Right? Imagine that. You would write the code, but you would never be able to tell until 2 weeks later if that code has actually been through compilation and what the errors were. So you could guess and you could but at the end of the 2 weeks, at the end of the iteration, the code would compile and you'd see all the errors, and then you'd have a whole 2 weeks to fix all the errors that you had in the previous compilation, right? Actually, it used to be like this, right? It used to be like this. People would take cars to the mainframe and then wait, etc. But, hopefully this doesn't exist anymore. Today we have continuous compilation, right? When you write something, you immediately know whether it holds up to reality as quickly as possible. That's kind of nice, and we take it for granted. Okay, sure, compilation. That was a really nice, simple thing to say. What about tests? Imagine that you could write maybe unit tests, but you could only run them once every 2 weeks. Okay, you could write them and you could guess whether they actually worked or not, but only after 2 weeks you would actually run them. And I think today, some teams have that, some teams don't. Some teams still don't have a lot of, or even some, unit tests. So they actually don't get that feedback. But for teams that do have that, not having that feedback on a daily basis or multiple times a day is just a horrible feeling because you feel like you have no idea whether you're on the right track or not. But today we're closer to having continuous testing. So when we write the code, we right-click maybe and we run all the tests. Maybe we have auto test running. So as we compile, it automatically runs the tests. So we get that immediate feedback that not only does our code hold up to reality of the compiler, it holds up to the reality of what we think it should do. Cool. What's the next level? How long before we deploy the code to the customer's machine, to the production environment? How long? Imagine, you don't have to imagine probably, imagine that you have to wait 2 weeks or 2 months until you can deploy your code and your application to the production environment. And in some projects, it could be 6 months from the first time you actually write the first line of code to actually having an environment that you can deploy to. This lack of knowledge, right, it works on my machine, is a sentence that everybody knows for a reason, because it never works on anyone else's machine. So deploying every 2 weeks until we get to that feedback is still not good enough. We might be working for 2 weeks on the wrong thing. We might be working for 6 months on the wrong thing. Maybe the whole thing doesn't work on the machine that looks like what the customer has. And so all these things, they make us work in the dark, basically. What we want is to move to the next level, to deploy continuously, so that when we actually write a piece of code, we don't only know whether it lives up to the compiler or to what we think it does. We know it lives up in production. That in production you could run acceptance tests for it in production, that you can actually deploy it into a production environment with all the mess that's required. And we'll talk about some of that mess, right? A lot of permission issues, a lot of security-related stuff. We have no idea what it's like for our application to run in such an environment, for many of us. And to me, that's all about continuous delivery. Not only does it get deployed, I want the customer to use it in production, so I get feedback that this is what they actually wanted. Nothing makes me happier than, of course, it looks weird, but nothing makes me happier than deploying it, getting the product owner or a customer looking at it, and then saying, oh yeah, that's exactly what I didn't want, right? But I'm happy when that happens, and of course, the team members are usually like, yeah, that sucked. I'm like, no, that's great, because it sucked earlier, right? It would have sucked 6 months from now anyway, so at least we know about it now, so we can do something about it. So it's about getting the feedback. So that feedback, that it lives to everyone's expectations, not just mine, is very, very important. So that's what continuous delivery to me is. And then now everything else is just about what corners can we get rid of so that we can do this as quickly as possible. So where do I start? If I start with a new project, one of the main problems that I've come across is that if I don't do this, I have this problem. Is that when you get into a project that's already existing and you want to start automating things, it's just a horrible way. Sorry, go away. It's just a horrible, horrible experience to automate things in an existing project which didn't do it in the beginning. Because there are too many things already in the air. So we start doing something and then we realize there's a million other things that we still have to do, and nobody has time to do it because we're in the middle of a project. So the pattern I want to talk about is called shipping skeleton. You might have heard about a dancing skeleton. A shipping skeleton is based on a pattern called a walking skeleton. Who's heard about this? Okay. One person had the nerve to raise their hands. This is a pattern by Alistair Coburn. It took me a while to say his name correctly. And in this pattern, it's basically about creating the simplest version of your application that you can start then adding things to, and you can start adding tests to it. So it's about having this skeleton of the application. What I want is to ship it. So if I want to actually have a shipping skeleton, it means that I create the skeleton of the application, but I also create the skeleton of the pipeline where that skeleton will transfer through. So that means that in iteration 0 or iteration 1 of a project, the only thing I will be doing is setting up the pipeline and having a hello world program that gets shipped all the way to as close to production as possible. So I might have a program that looks like this, just says hello world to the console. I don't care what it does, but it should be able to output something. And then I'm going to take this program and I'm going to create a pipeline that doesn't do anything except move it through all the stages. For example, I'll have a stage where I run all the tests for this program, which of course it has 0 tests. But I'll run them. I will run those 0 tests. so that when I have a test, I won't have to do anything. It will just start running. And I will deploy it to a test environment, even though there is nothing to test. Because when there will be something to test, I will have nothing else to do but to keep adding more features. And I will also deploy it to staging and to production. Actually, I want to start with production as quickly as possible, because at this stage, there is no production yet. So I'm not interfering with any existing application. So I can actually deploy to production in very early stages. Even if it's a website, I can deploy to the server with the IP address, but not have the DNS actually connect to it, and just protect an application with a password. But if I can do that, if I can deploy to a production server, where all it takes is a DNS switch, on the first month of the application, and now I have this whole thing, and all I need to do now is just fill in the blanks, then I will never have to worry about this ever again. Whenever there's something else that I need to do, I just add one more extra thing. Oh, now I want to run integration test, one more line into the build script. Now I need to deploy to have an FTP or to zip a file. Okay, one more line. I don't have to go and start creating this whole mess. It's kind of like when you have a hotel room. You know, hotel rooms, they clean them every day, right? Why do they clean them every day? Because if they would wait a week, it would be such a horrible mess. Well, at least the rooms that I stayed in. That no one would ever just be able to just burn the room and just leave, you know. Just easier to just recreate from the beginning, the building. But we do that so that the next steps on the build will just be very, very easy. Also, there's another reason, is that when I start with the shipping skeleton, I've solved the most difficult problems for my project mostly. All the political stuff, right? Getting a production server and getting all the permissions and worrying about having the deployment users that is able to get to these things. And I think, especially those of you who are working in Java, you know that it could take months until those things happen. So you start on the first day, and maybe on the second month, you're able to deploy to production. And life is beautiful after that, because in these enterprise situations, nothing changes quickly. So once we get something working, we've actually established the facts. Now, the chances of us not having a production server tomorrow, the chances of that changing and disappearing are actually very, very slim. So we've actually created a very powerful groundwork that we can just go and just do as many demos as we want, and with the click of a button, we just ship. We want to add a new feature, we want a quick fix, we press something and we ship all the way through the pipeline. And this is a simple pipeline I would do, just compile, test, and deploy something. But the deployment and the testing and the compilation would happen continuously on every check-in. So the tactic, if our strategy is to get the feedback as quickly as possible, and we know it's difficult to set up a pipeline, then our tactic is to start with a pipeline. So I start by shipping, actually. And in the beginning, you just need a build machine that maybe an agent, maybe two, or sometimes just a single agent. Test environment, a staging environment, and a production environment. And if you can do that in the cloud, great. If you're working on a government project and you're not allowed to do it in the cloud, you're kind of screwed, I know. Get a private cloud. Private clouds have their own different sets of problems, because the companies that manage those private clouds for you, they're assholes many times. And you actually find that you fight more with the internal companies that are supposed to provide you service than you do with anything else you would find. But that's life, right? But you have to, because it's so difficult, you solve it first. And then everything else seems very, very easy. What, just add a feature? Code? I can write code. Getting a production server running? Now that's difficult. So we get that out of the way. So I start with that. Before I have that, I feel really, really bad about my project. Once I have that, everything else is just a breeze. Just add that, just deploy that, and I get everything running. Now, the difference between test and staging is that staging looks exactly like production. It will have the same permission issues, security issues. A lot of times we still can't get production, so we will at least get staging. Staging has to be as difficult as production, so that when you deploy to staging, you know that your deploy script works. Staging is as much about testing your deployment scripts as it is about getting feedback and sort of showing demos. It's a way for you to test your deployment. Without staging, if you're always deploying to production, you're also testing your deployment in production. So if you screw something, you're actually screwing up the production environment. Now, in terms of build configurations, what's a build configuration? When I try to explain that, it basically means that a build configuration is a single task in the flow towards customers seeing something. So I might have, it's a step in the pipeline. I might have a CI build. A continuous integration build is one that it's like already known as a step that runs on every check-in. It happens fast, but I might also have slower builds, ones that run the very, very slow tests. If I start with a shipping skeleton, those run 0 tests, but I still have them. It's very easy to create them once you have the previous one. Basically create a copy of that, and you run a different folder. Then I have the deployment scripts. Now, sometimes you're lucky and deploying to the test environment and production and staging will actually be the same. But sometimes, and a lot of times, the production and staging servers will be much more difficult to get into. So you will have a different script from deploying to test, and then you will have a separate script for deploying to staging and production. But it's very important that the script in staging and production is the exact same script. You should be able to deploy to both of them with just different parameters. Because if you need a different script for deploying to production, then you have not tested that script. So it has to be the same exact physical file with different parameters. Here's an example of what it looks like in TeamCity in a real project that I was in after about 3 weeks. So we didn't have integration tests, we didn't have slow tests, we just had unit tests, so we had 13 of them. But we started in the first iteration with a CI, and then we deployed to test, staging, and production. So this is a production server, and each one of them takes less than a minute. So it's very, very basic, and it's supposed to be basic and simple. And notice one other thing. You see the numbers on the left. Those are just part of the name. I put those numbers on the left so that I could see the flow. I could see what comes before each thing. It's very important, if we want our build to be readable, is that we can see where something starts and where it ends. So that numbering scheme also gives us the ability to put numbers in the middle. So if I want to add a step between those two, I just put 250 in that step, and the ordering happens automatically. And I just want to remind you, if you have any questions, feel free to just raise your hand and ask. Okay. So now that we have that basic shipping skeleton, when do we trigger things? You can trigger things in many, many ways, but I like to think about the feedback that the developer gets, and I want developers to start coding as quickly as possible. So a lot of builds and continuous integration setups today, they're not productive. You might already have this, but you're making your developers wait too long until they can start coding again when they check in. So consider something like this. The developer checks in, and then they wait for a CI build to finish, and it takes 30 minutes. So now that developer has to wait 30 minutes, or even more, until deployment, maybe even 50 minutes, until they feel absolutely sure that they can write a piece of code. Of course, they'll usually just wait for the first 30 minutes. But 30 minutes is too long. Okay? And of course, by the smiles that I see in the audience, I see that this is not a new subject. 30 minutes is, it should probably be 2-3 minutes, worst case scenario, sometimes 5, never 30. So what do I do? In this case, what I like to do is that I would split the CI build. Notice that in this case, I have a CI that does everything. It does compile and does running tests and also the slow tests. And then I have deploys. In this case, I've actually split this up into 2 separate builds. I have the CI build that runs only the really, really fast things. And then I have an automatic trigger for the number 20. So what happens is that the CI build happens, but also the slow build happens automatically. And this is something a lot of projects don't do, is that they wait until the nighttime to run all the slow stuff. And if everything is automated and you have more than a single build agent, there's no reason to wait. If you can give your developers more confidence, why not give it to them? Now, instead of waiting 30 minutes, developers might wait just a few minutes, and then just the fast tests have passed. Now, that gives them some level of confidence. And then the slow tests start running. So after 25 minutes, developers will get an automatic notification that the second build has passed, the integration build has passed. So they'll feel a bit better. But they usually will start coding after 5 minutes instead of after 30. So it's very important that we don't have just a single thing that gets triggered that does everything. But the thing that gets triggered does the most basic thing that will allow my developer have some confidence that, you know what, there's at least no smoke coming out of the machine. I can code again. So, types of triggers. In our setup, we had this triggered automatically and this triggered automatically. We actually deployed to test as part of our tests. So I would deploy to test and also have some acceptance tests running as part of this build to check that the website was running up, etc. So this would maybe take 10 or 15 more seconds. So then CI would run, and maybe after 40 seconds, the developer would know everything is okay. But then 30 seconds later, they would know everything is even more okay, because now the application also works in the test server. And it's actually running and loaded up. So the configuration and nothing got broken. But they all already feel confident of writing code after 40 seconds, hopefully. You might feel that 40 seconds is not such a big deal, but we all know even a second sometimes, just moving the mouse versus touching a keyboard can save us a lot of time and pain. And then I would have staging and deploying to production run manually, but only after we had made the first release. Before we had made the first actual release of the product, like the official one, I would have these triggered automatically and run. Until the such day where QA starts messing with the staging or the prod environment to start testing the various things. And then I can't do it anymore, and we'll talk about how to solve that as well. So we can have multiple triggers. I like to use the build finish trigger. So I would trigger the CI on every check-in, but then I would trigger, when the build finished, I would trigger other builds. So it would be like a domino effect. For example, I would, let's everyone say hello to this kid. So I would, for example, have a domino effect where I would trigger a CI build, and then that would trigger maybe even multiple builds in parallel that test every other variation in multiple browsers or anything like that. But it doesn't prevent the developers from already starting to work while all these things are running in the background. And I don't care that it takes a long time, because I have more than a single build agent. So parallelizing the work can help a lot. Oftentimes when we have acceptance or integration tests, then retry triggers are very important. A lot of people don't use them. Is that sometimes the build, a test would fail on some racing issue in some acceptance test, but if we run it again, it's very likely to pass on the second time. So for these acceptance tests, I would usually run things at least once. I would have retry triggers on the complicated builds, if you will, so that if something fails, it automatically already starts again. Because that's what I would have done manually anyway. Oh, it fails, oh, it's that test, well, just retry it. So let me save you that work. Now here's another common problem, is that the builds become slower the closer they are to production.
Yeah, I just have to protest a bit, because
Sure.
I mean, I'm allergic to rerunning tests, because you have absolutely no idea that you're not hiding an intermittent error in the code if you're doing that.
Perfect.
So I mean, that's I really have a problem with that.
Cool.
It's, well, I'm a pain in the ass in my country.
No, no,
well,
I think,
what I'm saying.
I think that.
But I say that anyway. So
Sure.
it's,
First
I
of
mean,
all,
yeah.
and it's good to hear that something bothers someone. That's good. If I was always right, then
I'm not
I
saying
would not be here.
Yeah, but I think it's a very common common way of working, but I think it's a very risky way as well. Because I mean,
Yes.
the risk is that it's, I mean, it might be an intermittent problem in the environment or in the test case, but it might as well be in the actual
Yes,
production.
I agree. I agree that many times when you have that, it's definitely covering up a deeper issue that you don't want to deal with right now.
Yeah, so
I
it's
agree.
like,
Yes. Yeah.
fine
But
to-
we're not talking about that now. But if I was doing a unit testing or a TDD talk, I would say that should never happen in a unit test. In an acceptance test where you're testing threads, if you care about that, then definitely that should never happen. If you don't care about that, then this is more of a testing tools issue. For example, in one of the projects where I was working with, the QA-related builds, they would have a lot of UI automation suites. And this was not web yet. So you know that UI automation on non-web applications is just the most horrible, horrible, horrible thing. And it always is unmaintainable, and it always works only 30% of the time. So when it fails only 30%, the QA are really, really, really happy, right? So the developer used to actually have this board that would show the QA builds, but the problem is that developers would get really, really sad because it will always be red, right? Because tests would always fail. But it would take a special analyst from the QA to see what failed to say, yes, this build is actually successful, right? So you need a scientist to tell because of the brittleness of the tools. So there are cases where the retry would have happened anyway. And I agree that mostly this is a problem and it covers up something. I fully agree with that. We are in the process of focusing on a specific different problem. So in the process of that focus, I'm okay with hiding that for now. But then the next, if we're talking about Kaizen and continuous improvement, I would then go with what I assume is a rifle to the QA department and ask them to fix this problem. Okay? And that's very important. But it's not about this right now. Right now it's about just a continuous feedback cycle. And it's this I want to know, that this build, if I see red, green, I know there's a problem. Other questions? Okay. If you have more things like that, please let me know, because I want to address them. Okay, there is no one way to do everything. So here's another case that always seems to happen to me, is that when I would automate things, the builds, the closer they were to production, the more they did, right? Because right here you would compile, check out, run the unit test. Here you would check out, compile, run the unit test, and the integration test. Here you would check out, compile, run the unit test, and deploy, and then of course the integration test. So obviously, if you're going to deploy to production, you had better do everything. That's like the most important build. That is the one that should take the most amount of time. And that is the symptom. The symptom is that the builds become longer and longer. The problem is that we assume that the builds should do multiple things, when instead we can use the tools that we have to make builds do only a single thing, or be responsible of only a single thing. So the pattern I'm going to show is called cumulative build. And the idea is that we take a single piece of thing, let's say it's our code, and then it goes through like a factory level. It has gone through compilation, and then gone through running unit tests, and then gone through deployment, etc. But it is never repeated. It is only going through one thing, and then that same thing goes through all the others. And this is what we call, and for that we're going to use a feature called artifacts. And most of the CI systems today support the idea of artifacts, except, for example, TFS, which doesn't support artifacts very out of the box, and it's very complicated, so you can't actually do what I'm going to show you right now with TFS. So the idea is that CI, the CI build, compiles and runs the unit tests. And then it publishes the artifacts automatically by the CI server, so that anyone can take artifacts from that build and then reuse them. So basically, in our case, might be a bunch of DLLs. And then the deploy the test would then, instead of compiling or anything, would just take the DLLs from the CI build and then just deploy them. It wouldn't need to check out. It wouldn't even need to use source control at all. Just take the artifacts directly from what that other build published and just copy them to the right location, push them to the right location. So all that time of checking out and compiling and running the unit test has been saved. And then another important thing is that the thing that I deployed the test is the exact physical thing that was tested, which I don't get if I keep recompiling. And then the exact same thing that was deployed to test is published. And then that same thing is deployed to staging and production. So that what I get in production, I know for a fact that it was the same thing that has gone through the entire levels. But I don't have to repeat myself to do it. So I save a lot of time. And this is why I can say that each one of them takes 40 seconds. Right? They all take kind of about the same. They don't take longer. And you'll find that this takes a minute. It takes longer than the compile because this does all the checking of the website. So it waits for 404 to be over, for the IS to reset in this case, etc. But then it loads. So it's basically the smoke test to show that some pages are loading in the website. So these things, they would have finished in 10 seconds, but it takes 1 extra minute to test those pages. But it would have taken 1 minute and 40 seconds if I didn't use artifacts in this case. Now, that means that if I press, if I get this, then in less than 5 minutes, I can have a full deployment of the full pipeline and actually show it to a customer. Questions? So artifacts are one of those small things that a lot of people don't realize actually exist in tools like Jenkins, etc. But it's very, very important that you learn how to use them and save yourself a lot of time. But if you cut it in half, they're already happy. They say, what if it was half X? What if it was a quarter? But you have to teach them that it's actually possible. It's more of a psychological thing, really. Other questions?
I have a question with a problem with my operation department. They don't deliver servers fast enough.
Your operation department, you're saying that they suck. That's what I hear you say.
No, they mindset is.
I'm just kidding. I'm teasing you, of course. They're amazing people.
Yeah. So my problem is I want to have a deploy server on demand.
Deploy of the month?
On demand.
I
Every time I want to deploy,
yeah.
I want to have a new server.
Okay. Okay. So you want a new server for each deployment?
Yeah. I want it for 1 or 2 minutes, and then throw it away.
Oh, okay. A throwaway server. Sure. What's the question?
How?
How?
Do it? Yeah.
Physically or psychologically? Because physically it's easy.
The stakeholder we have 300 Java developers, and we don't want to buy 300 servers.
Sure.
We don't have the money.
Well, this is more. There is a very important saying that all software problems are people problems. You know that, right? Yeah. So all you have to do is look at the people who make those decisions and see what bothers them. What do they care about that you don't even realize? And when you find out what they care about, you might see that it's actually easier for you to get to your target. As an example, one of the projects in a really big company where we would have an operations and IT security that would just wreak havoc. If we wanted the ability to create servers at will. But of course, the first thing that the project manager said is, yeah, that's great. Why don't you come to me with a budget offer? We'll have a meeting about it and tell me how much it would cost, and we'll talk about it. And of course, that means basically no. When we realized that this is about money, if this is about a single piece of budget, we realized that we actually could look at all the existing environments that we already have. If there are no throwaway servers, that means that there are probably servers that haven't been thrown away that should have. And then those servers, especially if they're run by a separate company, they cost money every month. You look for those servers that no one is using, and you say, you know what, we're wasting 30,000 servers every month on that server. Yeah. Let's shut it down. And for each server I shut down, I want to take that money and put it in my own budget. You know what? Even half the money. Okay? You create an Excel file and you show it to your project manager and say, this is the money we could save every month. Can I use half of it? And then you save that money and then you use half of it. As an example. So if they care about money, it's about money. So you look for a way to move the money between those different places. If there is no way to take the money from somewhere else, then you explain how much you lose by not doing it. For example, in another project, we had only 2 build agents, but we had 55 build configurations. So every build would wait in the queue for roughly 35 minutes if there were a lot of changes. What do you do in that case? So in that case, we didn't have anything to move in the budget. So we had to make the case of how much money do we lose every day by not purchasing, let's say, $30,000 worth of build agents. And then we could basically calculate the amount of time developers waited to start coding again, timed by the number of developers, timed by the number of days a month. That's a very, very easy calculation to make. And then, of course, you round it out and you change a few numbers, etc., to make sure that it really fits with the reality. But you come up with numbers that are just huge with it this way, because people are losing productivity every day on really, really stupid things, right? But no one ever talks about it. So all you have to do is pick from the million things that make everybody non-productive every day and say, by not doing this, we are losing 5 minutes per developer every day. How much do you pay the consultants on an hourly basis? That's how much you're losing. Divide it, multiply it, and you get a number. So if it's numbers, you can always find numbers. But you have to find out what do they care about. Maybe they care about their place in the department. Maybe they don't want anyone arguing with them because they have a really, really cushy job and they need the big budget because they're using it for something else. There's a frog somewhere. Did that start answering the question?
Yeah.
It's definitely a people issue.
I want the service that I can hire a server for 5 minutes.
Sure.
And I pay for 5 minutes.
If you can get it from EC2, just do it.
Yeah. And I want to distribute it over the world because we have sites.
Yeah.
6 or 7 sites.
So I once got actually my project manager's credit card, and I just signed up to Amazon, and I just did it.
But we tried Amazon, but it's not stable enough.
If Amazon is not stable enough, I can't help you. But it sounds like this is something that I would have to sit with you and talk to you about the specific circumstances. It doesn't sound like something I can solve in 3 minutes during a talk.
No. But I haven't
We could
tried
try.
the service yet.
How much time do we have?
I think we're counting up to 55 minutes now.
Left?
No, done.
Done? Okay. So we can talk during the break if you want.
Yeah.
Cool. Any other questions? We talk about the existence of God. That's also a good, simple subject to try to solve now. Just kidding.
Question what the artifact store, like next to
Sorry?
the artifact store, that you have to compile the...
What's the question? What is it?
Yeah, the question, how do you manage this big store?
What I like about this is that I don't have to manage it.
Yeah.
Some tools just manage it for you. I use TeamCD, I don't have to worry about it. It just works.
Okay.
I don't have to do anything. All I need to make sure is that I have a large enough hard drive. And then I can also set rules for when to do cleanup, like how many builds back, how many successful builds back, and it just works. Every day at 5 a.m., the old builds get cleaned, so all the old artifacts that I never need. But I get to keep history or just statistical data. I can keep the binaries, whatever I want, but I don't have to worry about it. So that saves me time. I don't have to mess with it. That's perfect for me. Cool? Yeah.
Are you dependent on a branch strategy to having the correct builds? Because if I work on some items which I am not done on, say, for 3 weeks, I don't really want to release it to the...
They say it's a great question. When's the next slide? That was a great question. Yes. We'll talk about versioning. When do you want to take a break? I just want to make sure that you guys are not just want to kill me in your heart. When are we supposed to take a break? How long before the next break?
We don't have a plan.
We can just go ahead?
Yeah, so
Yep.
whenever you feel like.
Okay. 5 minutes, we'll take a break, okay? People? Are you okay with that? And it will just be 5 minutes break also. Okay, let's talk about versioning, because that's a very important question. Because the branching strategy is also very important, but we haven't gotten to the branch yet. Let's talk about versioning when you have multiple components and they depend on each other, because that happens too. So let's say that we have this exact situation. Component 2 relies on component 1 and 4 to do its bidding. Component 4 requires component 3. In a lot of places, we get the artifact. Unfortunately, and this of course happens, is that component 1 has actually been failing for 2 weeks. So the artifacts that I get are from a build 2 weeks ago. So I actually get version 101. I'm already in version 103. So I'm getting an old component with old features because that build has been failing for 2 weeks. Cool? Component 4 is actually one version has been failing for just in the last build. And that there's a developer trying to fix it for like a couple of days now. So I'm going to get a different version of that. So I'm going to get version 102 from this component. Cool. Component 3 is actually in a much better shape than me. It's actually ahead. It now has more features. It has been running faster. So they've had more check-ins. They've had more features. They're a smaller team. They run faster. But unfortunately, their last build is also failing. So I don't get all the new features. I get all the old features. When I get 104 finally, it's actually not good. I'm not going to be able to compile with it because they changed their APIs. But I don't know it yet. So what I get with component 2 is that I get all these screwed up versions. And that's one of the problems that we had in one of the projects, is we set up all these beautiful artifacts. And everything seems to be working great because all components compile at some point, and then all these things come in and they're laid out nicely next to each other. Unfortunately, after deployment, half the things don't work. And nobody knows why, because it's like 3 different versions of everything. So there's a way to solve it, and this is called snapshot dependencies. And a lot of CI servers support this. And again, I'm using TeamCity as an example, because that's the one I have the most experience with. But I'm pretty sure that Jenkins has this ability as well. It's just not called snapshot dependency. And again, TFS doesn't have that. So from now on, just if you have a question about TFS, if it has that feature, the answer is no. Okay?
So what do you do instead?
What, instead of TFS?
Remove it?
Remove TFS? Well, if you can't use something, you can't use it, right? So even in one of those big governmental projects, we started using TeamCity because some things just cost too much money. You can actually show just the amount of time by these versioning issues of having developers. You actually take the project manager and say, you see all these people sitting there, not doing anything? That's because we're using TFS. Not for source control, but we're using it for the build. We should be using a different tool that would have been solved by now. So these things work. It's not easy. It takes a few months, but if you trickle it down, that knowledge will actually change people's minds. Okay, snapshot dependencies. So I can actually say, look, I have an artifact dependency. I get an artifact from here to there, but I also want to set a snapshot dependency. A snapshot dependency means make sure that this is always the latest version. So if the latest version doesn't compile, don't just not bring me artifacts. I want you to fail my build, component 2 build. So component 2 will not build until all these 3 get built successfully in the latest version. So if component 1 is failing, I have a dependency failure. Component 2 will actually fail even though it compiles just fine and all the tests are passing. It will actually not even start because this dependency has failed. Yes?
In what case would you not want to have a snapshot? I mean, to me it sounds like you always want to have snapshot.
In what case would you not want to have a snapshot? There are cases where you don't want to have a snapshot. When you have a known stable version that is not changing and the new version is creating features that you don't want to introduce into the product just yet.
Yeah, but
so you can have a pinned version with a snapshot dependency on a specific version of the component where you make sure that that specific version always works. And another feature of these things is that it will not repeat a build if it already succeeded. So if a build has been built and it is needed by multiple other components, it will not repeat itself. It will just give you the artifact again. If this fails, of course our component 2 fails. Even if this fails, it will fail that component, which will fail that component. So it only takes one in that whole domino line to fail my build. And that's actually a very good thing, because if we want continuous delivery, we want to make sure that all our components are deployable. They're in the latest, best version. And they're all in the same version. They're all in the latest and working with each other. So I might actually have this build succeeding, and then suddenly this will not compile with the latest successful version. Because the developer on their local machine might have version 103. The CI is already smart enough, because they're building everything from source, to say, well, on version 104 you don't already work. So developers can actually get that feedback. And that's truly integration, right? You integrate the latest version, and you see that in real life, your API and their API don't work together anymore. So you should get the latest compiled binary version of that component, and then fix your source code, because you don't work with their API anymore. Cool? So now we can actually have integrity. And that means that all components are in the latest exact version. And if tomorrow one of them fails, it will trigger a failure in the top one. And again, those that have actually passed, if tomorrow I just change the source code to this, but these have not been checked in, then the build will actually queue all these 3, but then they will pass immediately, because nothing will actually happen. They will just give you the artifacts from the previous build, because the previous build contains the latest snapshot from source control. So when I say snapshot, it means source snapshot. The tool is smart enough to detect source check-ins and say, this is the latest check-in, there's nothing else to do. So if we take this idea of snapshots and we put it on my existing project, I also use snapshots to give an order of execution, not just order of visual flow. That means that I can never execute these builds in the wrong order. I can't just deploy to production without deployment to staging happening first. And I can't just deploy to that without that happening first. And I can't do that without that succeeding first. So that means that if I click the button to run prod, it will actually trigger all of them in the right order and run 2, 3, 4, and then finish. And if that's already done, then it will just redeploy to test, staging, and prod. And if those are already done, it will just deploy to prod again. Cool? So now I have this, it's basically like connecting all of them with a string and just saying, you see, you hold this piece of string, and if you pull this, it will trigger your whole application. It's like a dynamite cord, you know, in those cartoons. I don't know. I have no idea why I said that. Okay, with that, we will take a 5-minute, how many minutes break do you want? 5 minutes or 10 minutes? Raise your hands if you want 5. Okay, 5. Okej. Ska vi fortsätta? Okay. So, that was an example of what happens when you have a component. What the hell is going on that right side? Listen, don't let the pizzas come in now, because everyone will just want to kill me. It's like the worst timing in the world.
You say pizza?
Let's let everyone. Okay. So let's talk about multiple teams working in parallel, because that's we're going to make things a bit more complicated now. In the new design, we have now not multiple components, but multiple teams working on multiple components. So when we have multiple teams working on components, I don't remember what I wanted to say. Yes, we're going to have parallel build queues. So imagine that we have 1, 2, 3, 4 components. Each one of them will actually have all those queues. So if before I had 3 steps, now I have 3 steps for each one. They're actually separate projects in the CI configuration.
The whole place is going bananas.
This building is not as productive as I thought. Yes, please continue. Okay. So, imagine that. Imagine that you're only listening to me. And you're not paying attention to anything else. Or pay no attention to whatever's going on here. So in my in my case, in my TeamCity dashboard, I'll actually have 4 different projects, and in each one of them will have their own little parallel universe where the component gets released on its own schedule. So I could build all these components almost in parallel, but of course because I have dependencies, then they will build in the right order. But if I don't have a dependency on something, it can be built in parallel. But when I have that, I have to start asking myself, where do I get the artifacts from? Right? If I have a component and it needs other components to do its bidding, each one of these is basically a build configuration in its own little, from component 3. I can take it from integration test, maybe component 4 has integration, but some components might have more or less in terms of steps. For example, some components might have acceptance tests, some components might have UI, some components might not have integration test at all. So this actually could be longer or shorter. Do I always take the artifacts from the last one? Does that actually make sense? Maybe I can take something from the middle, because some things are not important. But what's important to me is that when I get the artifacts from a component, I always get the best version of them. And that's a very important thing, because I don't want to get artifacts before they've been tested. Cool? So I want to get them after, but I don't want to get them before integration test, so I want to get them after. But this forces me to think about where do I get it from each component. What I'm missing is a convention. Where do I get artifacts when I have multiple teams with multiple projects? And I call this pattern the tipping point. So I basically take this existing waterfall project for a single component, and I add one extra build configuration. I call it tip. And this tip doesn't do anything except publish artifacts. So I'm actually taking the existing system and I'm forcing it to do something it was never built to do, and that is, for example, in TeamCity, all build configurations are supposed to do something. You can't just have a build configuration with no steps inside it. So I forced it to exist by adding it like a step that just does like an echo hello world or something. And then I just publish the artifacts that I get from integration test. So this has a dependency on all the others. So I get the artifacts from CI, because there is no reason to get artifacts from integration test. Because what I have is that I have snapshot dependencies. I'll get the artifacts from CI, but I can never execute before this and this have actually passed. So I get the artifacts from the build that has them, but I make sure that before I execute, all the builds have actually been built. All the build configurations have run in the correct order. So I have snapshot dependencies, and I have one artifact dependency. But now I have the best version of those binaries in the tip. And that means that whoever wants to take the artifacts from this component always uses just the one known extension point, and that is tip. So that's the tipping point. So in this case, it would look something like this. I would have all these components, and then each one of them can just take from the tip the artifacts for each one. And again, these are actually 4 different projects. It's not the same project. So each one of them can actually look different. They might have more steps or less steps, but they all have that flow. And then I could have a bigger, one last project, which I call the deploy chain. And in that, I have a step called system integration, deploy to test, deploy staging, and production. So each component here can have its own test servers, can have its own staging servers. We don't care. Maybe it doesn't even deploy to anything. Maybe it just has CI and unit test. That's okay too. I don't care. What I care is that when I deploy to system integration, I take all the artifacts from each project, and I don't care where to take it. I just look for that thing called tip, and I take the artifacts from that, and that tells me that by definition, what I get is the best version of those binaries. And this is actually a snapshot dependency. So when I trigger system integration, what I get back is actually that's not a great idea. Maybe you want to hide the smell of the pizza while people are listening to coffee.
Pizza, it's, I don't know, just boxes.
Oh, it's just boxes, okay. It's just a new iPhone. So if we have that snapshot dependency, that means that when I trigger this, it will actually trigger all these components. And if they have dependencies between them, they will trigger themselves as well. Each one of them will trigger its own little cycle. But again, I only have one endpoint to trigger, and that is this one. And then everything else will just take care of itself, because all dependencies are already circulating in the correct order. Any questions?
Question, does it mean if one of the components has failed the build, does that mean that it doesn't have any tip, as you call it?
Yes, exactly. So if, for example, if 20 on component 1 fails, this fails.
Yeah.
You're absolutely right. I cannot finish the build until all teams have a working version. That's absolutely right. Questions, thoughts about that? Is that good, bad, scary, amazing? It could mean that you could spend most of your day red here, but when it's green, it's fully green, it's deployable green. It means that when this is green, you can actually take all these and publish them, because they're all working versions in the exact same snapshots. That's an example of working on a main line. Main line is one of those best practices that you hear about when you want to do continuous delivery. You're working only on a single branch. All developers are using feature toggles, but when everything works, you can just take all those latest versions and just deploy them. And that is the way to ensure that everything is actually okay. Have snapshot dependencies on the tip, and the tip actually makes sure that everything else is working. When everything is in the last version and working and not failing, and you get to deploy it and you can test it here, then you actually have the latest version of all those components, and you can do with it whatever you want. Cool, right? That's a beautiful build. You trigger something, and then you see the queue light up. Now this is working, and these two are in parallel. This is waiting for these two. When that happens, oh, now that fails. Now all these are waiting for that one to fail. Now you have 3 team leaders coming to that components team saying, hey, the build's failing. Right? And now that team is actually under pressure to say, okay, we should probably do something to make sure that we can actually do, that nobody's just waiting for us. It gives people a bit more reason to fix the build. And it's okay to break the build. And that's very important that you realize this. Breaking the build is actually a very good thing. I used to be one of those people who would say, you know what, let's give a shirt, a special t-shirt. I broke the build to whoever broke the build. Or you have to get ice cream for everyone. Or whoever wears the hat last broke the build yesterday. But that's kind of almost like a shaming culture, although it's kind of fun and funny. We don't want people to feel ashamed or weird that they broke the build. Breaking the build is okay. It's another form of feedback, right? It's okay because I might realize that these two components don't work together because they don't compile in the latest version of the APIs. So what I would do instead is I would be happy that I broke the build, just like I'm happy when the compiler tells me I screwed something up. And if I'm happy with that, I should be happy with the build. The only thing I should worry about is that when the build fails, it actually stops the line, it stops the chain. And then we do whatever we need to do to fix it. going back to our example of components, here we had a version of dependencies of multiple components into a deploy chain. I want to talk about the dependencies between multiple components in this regard. I explained a little bit. This is a different example. Component 2 relies on 1, which requires 4 and 3, and 4 also requires 3. So you could have like a directed graph of those dependencies. And I want to explore another problem that we have when we have these components. Sure, we have the tip, but now we get into a different problem. When we have those components and they rely on, each one relies on the tip of the other, if I want to compile the component 2, and it relies on the APIs of component 1, which relies on the APIs of component 3, etc., then when I want to trigger this, I have to wait for all of these to end, right? But in an environment where I would say, you know what, these are service-oriented components. I don't care whether they work or not, just give me the API. Why do I have to wait for your unit test and integration test to pass? All I need is your binary contract. But I still have to wait for the entire thing to work. So that means that it really slows our system down. This was good enough when I wanted to deploy to the production or to staging all the components together. But between two components, if all a component needs is to just the API for that component, it doesn't care if the component works or not, then this is actually beating the purpose of the integration. Because I'm waiting for something I don't care about. So if all I want is the API, how can I speed things up? So in this case, we're going to introduce one extra integration point. We had the tip, which is all about deploying. Right? But instead of waiting the whole, just for the tip, we were waiting for all this. So now we're going to add one more thing. So we ended up adding a configuration called public API. A public API means that we're structurally separating a component from its API. We have a binary for the API that gets compiled separately. It's a separate project, a separate solution in our case maybe even. And the CI will compile both the public and also all the logic, but the logic is separate from the API. Now what's nice about this is the API can be compiled and then we can use it in other components. We don't have to wait for everything else to actually run. So it can speed up our application. So in this case, instead of waiting for the tip, I just wait for the public API, which is very, very fast. No tests are running, nothing, just compilation happening. If all I want to make sure is that the latest API is compatible with my API, then I don't have to wait for everything else. Because that component will have its own tests, and that's okay. It will figure things out. And that allows me not to wait and have a much, much faster build cycle. But it forces me, in terms of architecture, to separate the component and its API into two separate projects so that I can compile them separately. Questions? Yeah.
So how do you handle this with versioning? If you have the...
Well, you see those purple? Yeah. Those are snapshot dependencies. So obviously I get the artifacts, but I put snapshot dependencies on the public API. I use the tip for deployment, but with inter-component dependencies, I use snapshot dependencies on the public API instead of the tip. And I use the artifacts from public API. That help? So it still makes sure that I'm in the latest version. I just don't have to wait for everything else. And now, I also said that I don't want to repeat myself. But in this case, public API and CI might actually compile the same thing twice. If that ends up happening, then I would actually have a sub-step here that copies the public API binaries onto CI. So that I know that the things that other components are using are the ones that I test and deploy all the way throughout. So you might need to do that as well. But that's like a very, very small nitpick that you can do very easily. Other questions? So this is really what it looks like in real life. You have snapshot dependencies between components. You see the graph here basically. Component 2 requires this one requires those two, etc. Deploy chain doesn't care about the inter-component dependencies, it just cares about the components. So it takes the tip of each component, and that's it. So we have multiple snapshot dependencies, we have multiple dependencies between different things, but when I trigger this, it will actually trigger this one last, this one first, because these two depend on it. Everything will just happen the right way, in the right order. Hold on. One last thing that this gives me is that is an extra bonus that we've never considered until it happened to us. A developer in one of the teams came to us and said, well, Team CT is yelling at me. It says I'm trying to do a circular dependency. It turns out that he tried to add the dependency between this component back into that component. And a lot of times you don't even realize that that's what you're doing, because the system is maybe so big and complex. But when he tried to say, okay, so give me a snapshot dependency on the artifacts of this public API, Team CD actually said, oh, you can't do that. That's a circular dependency. So it actually saved him from himself, because the system is built based on the architecture. So we can only have a direct graph. We can never have a circular graph here. Yes, what's the question?
I was thinking if component 3's build is based on public API of component 4, and then runs the unit tests before component 4 actually have run its unit tests.
Sure.
Wouldn't component 3 possibly fail because component 4 is not complete?
Well, the point is that component 4 is a separate autonomous entity. We only care about its APIs. It's okay that it fails because that will fail this build. So we won't be able to deploy the application anyway. But we don't want to depend on the logic here, which is actually a good thing, right? Components shouldn't care about each other's logic, just about the API. So I don't have to wait for the logic to pass. Okay? Imagine a REST API, so it's not even binary. I just want to have a REST API that I work against. I don't care what logic you have. Do you have the REST API that I'm expecting to work with? That's all I care about. If you don't work, the deploy won't work. I'm still good on that regard. So I don't have to worry if this one worked, will this one work? Because if one of them doesn't work, I won't ever get here anyway. Is that okay? Yeah. Other questions? Cool. Yes, you could end up with an integration test that would fail if you're using the component 4, but that one failed because that build succeeded, but it ended up failing. But you'll know. You will find out, obviously. But you will still see that this one fails and your integration test fails. It gives you a lot of clues as to what's going on. When builds fail this way, they will also say, this build didn't fail, but it depended on that build that failed. So you'll see like a chain. You don't have to play Sherlock Holmes too much to see what is the core problem here. Okay, this is a very common problem in large organizations, and that is security. I talked about production environment, and a lot of times you can't actually deploy to a production environment. You have to go through tests. Maybe you go through staging, maybe not. A lot of times you don't have permission to do it, but you still have to. We want to automate it. How can we do it without having a person go with a USB stick and deploy it to the production server somewhere on the other side of the world? Well, a couple of projects that I've worked with gave us the ability to go over this security barrier by allowing us to create a machine in a demilitarized zone. So this machine is able to see the production, but staging is able to see the machine. So it doesn't have physical contact here, but we can create an automated deploy script in the machine. We can even set up an automated triggers. So we can have a CI server running solely on that machine that listens to, let's say, an FTP shared folder, automatically processes it, and copies it to production environment. That's the kind of thing that a lot of security organizations are happy to do. They are just not happy with a single user having access directly into the production. As long as the access is not direct, but it's actually by an automated process, that it's not done by a human, a lot of IT security offices will be happy. Well, not happy, but it'll be possible to do this. So it complicates things a little bit, but it still works just as well. If you set up an automated deploy trigger here, all you have to do now is deploy to an FTP. Good, bad, amazing? There's actually a problem with that. I said staging looks exactly like production, right? So why do I deploy the staging separately? Look, I deploy the staging just by copying, right? Life is easy. If I really want staging to look like production, then this should actually be one to the left, right? I want to test my deployment scripts. If I do this and this screws up, it screws up production. I want to test it one step earlier. It should actually be here. If I have a staging environment, then I'll actually might have two. Maybe it's the same machine, maybe not. But I actually want to test my deployment scripts by deploying to staging. So this is where I can go crazy, right? Let's set it up this way and that way and whatever. When this finally works to deploy here, we know we can probably just change it or create a parallel one that deploys to production. So we could have a separate, something looks not like this, but maybe almost, by having just two lines from here to here and from here to here. We can just configure a parameter somewhere. Or we might need a separate machine. We don't know yet. But whatever it is, it has to be the exact same process, the exact same script, and then all you have to change is variables. And then you can test it on the staging environment, and you can screw up a staging environment. That's okay. Questions before we finish for today? Yeah.
It's also very interesting to get the automatic feedback the other way.
Automatic feedback the other way.
Let's say that you have a system that automatically collects profiling and usage statistics and so on.
That's a good idea. Yeah, that's true. I haven't thought of that, but that's a really good way. That's more about monitoring and understanding behavior. But I fully agree that in an application that wants to make sure that users are doing something or not doing something, yeah, you could also save it and then move that information backwards. Sure. It's a good way to steal information too. Other questions? Okay. So what we're going to do now, just to finish, I wanted to do a little something. I wanted to do a little song for you guys. I know it sounds weird, but I don't know why they brought me a guitar. They said, hey, if we bring a guitar, we'll do something. I said, sure. Fortunately, I don't know how to play the guitar, but we'll see what happens. So what I would need, if we were going to do this, I'm going to need a volunteer. You don't have to sing, don't worry. But I need someone to press space so that you can see the words of the song. Anyone want to volunteer? Okay, I'll give you an incentive. No, not you. The incentive is that you get a free copy of my book about the beautiful builds that I'm writing. Oh, wow, look at that. Look, he was second and he's still coming up. And he was first, actually. Are you kidding? I'll borrow it from you. It was so nice. Okay, cool. What's your name? Patrick. Patrick, nice to meet you. Okay, I guess it wasn't nice to meet me. Just wanted to clarify. Okay.
I just want your book.
Sure, okay. Just don't push around. Just say what you mean. Don't do anything yet. Okay, we're going to do a little test for Patrick to see how skilled he is, since I'm a test-driven person, how skilled he is with pressing space, but only when I finish the words on the page, okay? Okay. So just press space down so we can start. This is a test line. Looks like you're doing just fine. It's kind of slow. It's time for a song of mine. Perfect, okay. So it was good enough. Give him a warm applause for that amazing. I like how you're feeling so awkward. No worries, okay, I feel awkward too. But this is a song I wrote about a customer that we used to have. And then Bob Dylan took it and made his own song out of it. And this is basically, I used to work in this, it was a horrible, horrible company. And we were a horrible, horrible team. And every time we would want to show a demo or something, it would just not work. Nothing would ever work. It's just like, what's not going to work today? And then at some point it just got canceled. This is a song for that project. Did I say to press that? Our client likes to change his mind. We're getting tired of his games. No matter what we have designed, it all comes crashing down in flames when we're knocking on the client's door. You think we got it? Knocking on the client's door. Does it work on my machine? Knocking on the client's door. He doesn't trust us anymore. He had a dev lead that believes we don't need to write no tests. It was a long time ago. We don't have automated builds. And our culture looks like one big mess. But we're knocking on the client's door. We think we got it. Knocking on the client's door. Does it work on my machine? Knocking on the client's door. He doesn't trust us anymore. Thank you. Okay, with that, I'd like to thank you guys, and hopefully you had a nice time, and keep being productive in this amazing building, and I'll see you at some point. Feel free to contact me or just go to the site and watch some cool videos, and hopefully I'll see you at some other point in time. Bye-bye, cheers. Ha det. Right? You say ha det? Ha det bra. Well, hi do.
As you might have noticed, we had some boxes. They actually contain